Hello everyone. In this video I'm going to talk about what a quadratic function is. It is nothing but it is an algebraic function with the degree means power of 2. Usually all the quadratic equations are written as y equals ax squared plus bx plus c, where a, b, c are nothing but coefficients or numbers. They can be positive or negative, but depending on the graph of the function changes. Now, the graph of a quadratic function is called a parabola. Parabola, depending upon your accent and state of country, I think. Now, parabolas are quite important features to represent some real life scenarios, especially related with any trajectory motion. So check out the other videos that I'm going to do today on completely about soccer. So soccer has been a quite popular sport in our house at the moment because of the World Cup 2026. So I'm going to do a couple of quadratic equations and explain the features of this equation, but with a real life scenario using soccer. So you need to check out the other videos on that. Now, what are the other key features of this quadratic function? Now, these curves look a U-shaped. First of all, you need to know that they're going to be a symmetrical U-shaped curve, right? And they can either open a U or an upside down U. So depending upon the numbers in the equation, especially the leading coefficient of the x squared term, which is the coefficient we represented with the letter A. Depending upon that, the curve will either open upwards or downwards. And again, this is entirely a different topic, but for now I'm just touching the key features and I'm revising. So this video would have been quite helpful for the students who have already done a couple of examples of quadratic equations and then trying to revise or create like a cheat sheet for their preparation for any exam. So if a is greater than 0, the parabola will open upwards, and if a is less than 0, it will open downward. So many a times we call y equals x squared as the parent function. So if you see, it is a parabola and it is opening at the moment upwards. That's what I mean, because if you compare the leading coefficient, which is like the a, here is positive 1. Okay, so if it's a is greater than 0, which is all the positive numbers, right, the parabola should open upwards. Now these are some features here. So this point right here is called your vertex, and in this case the parabola is also touching it's not touching only x-axis or y-axis, so that's not our intercept, but it is our vertex. There's a special name which is called turning or it is also called as turning point, because this is the point where the curve is changing its direction, and it can be either maximum or a minimum. So in this case, this is the minimum or your lowest point. Minimum. Okay. Now what happens if in other words, what happens if y is equal to negative x squared? Now the curve has just opened downwards. And as you can see, this is again my this is, I don't know why I can't write it. Can you change that to, okay, fine, but I need to write on it. So let me see what's happening here. So as you can see, okay, I need to come out, probably that's why. So that is your maximum point, and still it's vertex, but it is the highest point of the parabola. And this happens when the curve is opening downwards. And we also can see that is also called as your turning point, because up until then the graph was going up and then it's changing its direction. So that's what I was trying to explain you. So we will do more details. Check out the other videos, but this is a basic understanding. I'm trying to revise the features of quadratic function. Then we also have something called as um, axis of symmetry. But before I do that, one of the ways to find the vertex can be with the help of the x coordinate of this vertex, right? So there is a formula. So your vertex x coordinate you can find out by using minus b divided by 2a. Now this will give you the maximum or the minimum point, and this is quite important because the next video that I'm going to do about finding the maximum height that the ball can reach, all this I need these formulas. So I'm just trying to recollect that or revisit that with you guys. Now then we also have something called as y-intercept. Your y-intercept can always be the constant value in the equation. So it is usually the value of c, right? And it can be written as 0 comma c. So based on the equation that you get, y equals ax squared plus bx plus c, this constant value will straight away give you your y-intercept. Now for x-intercepts though, again, this is an entirely a different lesson. I'm just covering it for you. You can, in some countries, they also always say roots or zero, especially if you're in America, this is what you would come across, the language. It is nothing but where the point touches the x-axis, pretty much. Y-intercept is the point where the curve touches the y-axis. We all know that. Now, there are two ways that you can actually do this. One, using the quadratic formula. I'm going to do a complete different lesson with examples on this, but this is just a recap, right? So your x-intercepts can be minus b plus or minus square root of b squared minus 4ac divided by 2a. So you just substitute your numbers and straight away you can get your x-intercepts. And depending upon this value or ABC values, you can say whether the graph is going to have either two x-intercepts, it can have one x-intercept, and it can have none. Okay, so there's entirely a different lesson. We'll talk about only the x-intercepts of the quadratic equation, but this is just a recap. Then other thing that I want to talk about is axis of symmetry. The equation would simply be x, because it is usually a line parallel to y-axis. So it is going to be x equals minus b over 2a. Now that is the equation for axis of symmetry. So I think I covered important features. Okay, so this is the axis of symmetry, x-intercepts, y-intercepts, vertex, and then once you get the x value, you can go back and substitute the x value and you can get the y value. So there are different ways to find the vertex, but I just wanted to show the x coordinate, and each piece is a different lesson. But this covers the overall topic of quadratic functions. I hope this was helpful. Check out some other videos